Hello, hello, pre-algebra. How's it going? Orange, you glad it's Friday? Today we are doing 13.6. We are talking about surface areas of pyramids, cones, and spheres. So if you didn't watch or had a really hard time understanding yesterday's lessons, today's going to be a little bit harder for a couple reasons. One reason is because yesterday we were talking about prisms. Remember the difference between prisms and pyramids? Prisms have two bases. Prisms also cylinders. Why don't I do it like that? Prisms and cylinders. They have two bases. But pyramids and cones have only one base. Right, ice cream cones, the Great Pyramids, they have one base and then they come to a point. So that's going to be something to keep in mind for today as we move forward with these shapes. It's a really similar process, right? At first we talk about, right, so pyramids have lateral sides with only one base, and the lateral sides are all triangles. The base can be different shapes. Right, it could be a square or a triangle. Right, we'd call that a rectangular pyramid or a triangular pyramid. But it's a similar process. So again, we're going to do the lateral surface, which is just the area of the sides. So if I had a pyramid, let's see, I'm looking for a pyramid. So let's say I have this, it would be like a triangular pyramid, right? So the lateral sides are going to be the ones that you see that are exposed. The base is the one on the ground. Okay. Now, the formula is that the lateral surface area is 1/2 the perimeter times, now the L is the slant height. Remember, because these are all triangles, so the sides are all triangles, and the area of a triangle is 1/2. So that's where the 1/2 comes from. The base times the height, where the base is perpendicular to the height. Meaning that the slant height has to be perpendicular to the base. It's got to make a right angle, 90-degree angle. So I'm using a lot of shorthand, but all these things we've talked about and covered, so none of this should be new for us. Here, and then when we're talking about surface area of a regular pyramid, it's the lateral surface area plus the area of the base, right? And there's only one base. Yesterday we had two bases, but there's only one. There's only one base for pyramids. Okay. Don't worry, I've got a big example here. Okay, so here we've got a square pyramid where our base is 10 by 10. Is 10 by 10. Now notice this angle here, this dotted line. So the edge, right, these edges, right, if this was the edge, now this is a triangular pyramid, but what my pencil's touching is the edge. That's not the slant height, that's the edge. The slant height goes right down the middle, right, it goes right there. Or in this case, it's coming here, right, and it's going up the side of it, right, because it needs to make a 90-degree angle. If we were, this is a triangle here, if we were going to find the area of this triangle, we're not going to use the edge, we've got to use the slant height. We've got to use this here. Okay? Now, this one, it gives it to us, which is really nice. So we know the lateral area is going to be 1/2 times, well, let's see, the perimeter of the base is going to be 10, and there's 4 sides, so 10 plus 10 plus 10 plus 10, so it's going to be 1/2, 40 times 13, which is the slant height. 1/2 times 40 is 20. 20 times 13 is 260. And then my units, again, are meters squared. Anytime you see area, you know it's going to be your units squared. Right? The perimeter, again, is 10 plus 10 plus 10 plus 10. Right? That's kind of shown here, so we're just going to have to include all of that together. Okay. Now for the total surface area, it's going to be the lateral area plus the area of the base. Well, the area of the base is going to be length times width, or my side, because it's a square, my side squared, same thing. My base is 10 times 10. So it's going to be 10 times 10 plus 260, leaving me with 360 meters squared. So for this triangle, right, if I wanted to cover it perfectly with wrapping paper, I would need this much wrapping paper. 360 meters squared. Okay. I've got another example here. Okay. So this one, I'm not shown my slant height. Okay, we're not always going to be given all of our information, but what I am shown is, so I've got 20 by 20. Therefore, I know half of this is 10. And that matters because this distance from the base of the square all the way to the tippy top, right? Imagine this was the Luxor, the light that's shining from the top of the Luxor. Well, continue that line all the way down to the base. From that, that's what we have as at 24 here. Now we could do the Pythagorean theorem to find our slant height. Right? So this is the little triangle that we have on the inside, right? This is the inside part of the light of the Luxor. 24 looks like feet we're working with. And then 10, because that's half of the length of the square. Right? Pythagorean theorem is a squared plus b squared equals c squared. That's going to give us, let's see, where's the work for that? Well, let's just work it out right here. Yeah, let's just work it out. So we have our legs. So 100 plus, what's 24 squared? And dandy calculator. 576 equals c squared. 100 plus 576 is 676. So the square root of 576 is, let's see, where's my little square root dealio? 76 is 24. Wait, oh, duh. I'm looking for 676. I was like, I don't know if you heard my surprise. Oh, it's 26. That's really nice. Okay. So C equals 26 feet. So this is also my slant height. And now I can include that in my lateral surface area formula. So my perimeter, the perimeter of my base is 20 plus 20 plus 20 plus 20, so that's 80. So 1/2 times 80 times 26. 1/2 of 80 is 40. 40 times 26 is 1,040 units squared. Oh, it looks, I thought it was feet. Okay. So now our surface area is going to be this plus the area of the base, which is 20 times 20, 400. Right, I'll do that over here. Base